Hi guys, I'm back again for the second part of the yeast investigation, and this is the bottles of yeast and the conditions that yeast need to grow. So we are going to come back now and have a look at all the bottles, and while we are doing that, you are going to fill out the second column, the 30-minute observations of what happens to the yeast. So number one, you are going to see that once again nothing has happened in this investigation. Inside this bottle, nothing has happened. Nothing has happened in the balloon, and nothing has happened inside the bottle. Our second investigation, where we have cold water and sugar, we can see that a lot of the yeast has collected at the bottom. The water is cloudy and there are a few, very few bubbles on the top. Now there has been a little bit of air, or actually now that you know the proper, it is CO2 that's filling up the balloon. So you can see that there is a little bit of CO2 production from the yeast growing. Now I promise that if we left this experiment overnight, the yeast would grow. It's got sugar and it's got a liquid, and the yeast will grow because it's got some of the conditions that it needs, and the other thing that it needs, that yeast always needs to grow, is time. So if we gave this experiment enough time, it would eventually start filling up the balloon. And some breads and bakeries use this method as a form of cold proving. You can actually also prove in the fridge. It will just take a lot longer than if you prove or grow your bread, your yeast, in a warm environment. So number three, the one with boiling water. Now we can see here that the one with boiling water has got no bubbles on the top whatsoever. Okay, we have got a lot of yeast collection in the bottom. The water is a very different color to the other bottles. I'll try and focus on more of the bottles for you, just so we can see. So if you have a look at the one next to it, can you see the different color of the water? There is absolutely nothing happening in this bottle, and it's the boiling water. As in, there's no bubble formation, sorry, there's a lot happening. So all the yeast has collected down the bottom over here, and there is nothing in the balloon, absolutely nothing. In fact, the balloon is being sucked further and further into the bottle. So we know that no CO2 is being produced in this bottle. I'm going to show you. Alright, it's actually, I mean, the balloon is just collapsing in on its, oh, see, there, it's just popped straight into the bottle and it's ended up in the neck of the bottle. So we know that there is no CO2 being produced in this bottle. Now, in a different one, let's have a look at our control, and I'm going to focus on that balloon. What do you notice about that balloon? It is absolutely filling up with something, and that something is CO2. So our balloon has popped up, and we can clearly see that what's happening in this bottle is quite a different reaction to the others. If we move further down the bottle, we can see that there is a significant amount of foamy substance here, lots of bubbles going all the way up the bottle. And that shows us that a lot of the CO2 is being produced by the yeast growing, which is what we want when we are making bread. There is very little variation. There is not a layer of yeast on the bottom, and everything in the bottle is a uniform color, which means the yeast has distributed itself throughout the mixture. The sugar working with the yeast is loving it, and we have created the perfect environment for yeast to grow. It's got warm water, it's nice and warm, it's got some food, it's very happy. So it is producing and growing at a rapid rate. Number 5, where we just used warm water, we can see that there is a little bit of bubble formation, nothing much more from the first observation. There is still quite a lot at the bottom of the bottle, and we have nothing in the balloon. All right, we have tiny amounts of CO2 in there from that bubble formation, but not a significant amount. Sorry, that was number 5. Sorry, that was just with warm water. I've mixed mine up. So I'm going to move that again, but we've done number 5 now. Number 4 is the one where we put salt into the water. Now, we can see immediately that there was some initial action of the yeast. It did try to grow at the beginning because we've got a little bit of bubble formation at the top here, or foam formation. But you can see if we compare it to one of the ones next to it, can you see the difference in the color of the water? You can also see that the majority of the yeast cells have sunk down to the bottom and they've separated out from the water. They are not happy. Nothing has happened in the balloon. Almost nothing. There's a tiny amount of CO2, but I mean it is almost insignificant, right? So we can see that there is very little going on in that bottle. And then our last one, which was warm water and flour. Now the warm water and flour is an interesting one, okay, because we've given it some food, we've given it flour, but most of the flour has sunk down to the bottom of the bottle. There has been some formation of CO2, of some foam, and there has been some formation, of CO2 in the balloon because we've given it food, we've given it flour, but the food that we've given it isn't the one that it likes as much as sugar. So again, this experiment will work eventually, but it will take a lot longer. That is why we almost always add 1 or 2 teaspoons to our bread or our pizza mix to speed up this reaction and for it not to take such a long time. But again, if we left this experiment overnight, we would see a more significant reaction inside the balloon over a longer period of time. So what we can conclude from this experiment is several things. So I'm just going to zoom out and try and focus on a few more of the bottles. Okay, so now that we've had a look at all those and we've recorded our observations, I want you to turn to page 2 of your investigation sheet, and this is all about our conclusion. So we know that while we've been doing this experiment, it has not occurred straight away. Okay, that is why we observe initially when we do the first experiment, and then we wait a while for a reaction to take place, or to see if a reaction will take place, and then we record results again. And this is exactly what you do in science, guys. You do an investigation and you will record your results at different times. You will change things in the experiment and then record the results. Recording results and observing what happens is actually a very, very important part of cooking and baking especially. And if you know what those reactions are, it's going to improve your baking or your cooking. So I'd like you to have a look at your worksheet, and you are then going to answer the questions in the box. Did the reactions take place immediately? And then you are also going to write which sample produced the most carbon dioxide, and you're going to tell me how we know this. Okay, describe what you could see. So don't just describe one aspect. There were loads of things that actually happened within that investigation. So you need to talk about the balloon, you need to talk about what was happening at the top, inside, everything that you saw that happened. You can rewind the video to actually see a difference. You can look at the first video to compare them so that you can see exactly what had happened in that bottle. And then I want you to write whether you think the investigation was a fair test or not. And that refers to, did we do this changing only one aspect of the investigation at each time. So in each investigation, this investigation is actually in two parts. So the first 3 investigations, we were focusing on the temperature of the bottles, so and the liquid. So we were looking at nothing, we were looking at cold water, and we were looking at boiling water. So we were looking at the liquids in the bottle. So if we don't add liquid to yeast, it can't grow. If we add cold water, it will eventually grow, but it'll take a long time. If we add boiling water, it kills the yeast. Now that's very important to know, pardon me, because if you want to preserve something and you want to kill bacteria or yeasts or molds that are going to grow, boiling it is a very good way. And then obviously in our control, we had warm water. So we know that out of the waters or the liquids, the warm water produced the best result. And then in the second part of the investigation, we were concentrating on the food that we gave. So in this one over here, we gave it sugar, and it obviously really liked the sugar. In number 4, we gave it salt, and it did not like that. It killed the yeast, and it changed the color of the water, so all the yeast cells sank to the bottom. In number 5, we gave it no food, and in number 6, we gave it flour. So sugar, salt, nothing, and flour. So from that, we can deduce that it really liked sugar. It really, really liked sugar. It did not like salt at all. With giving it no food, there was very little reaction. And then giving it flour, there was some reaction. All right, and we know that I've told you that if we leave that for a longer period of time, it will actually, because we have given it some food, it's just not its favorite food. Sugar is definitely its favorite food. So you can then go ahead and answer if you thought the investigation was a fair test, and explain why. All right. Now the last thing that we have to do is we have to go back to our first page, and we have to look at our hypothesis. So our hypothesis said it was what we thought was going to happen at the beginning of that investigation. So we put down our prediction. On the last page, we are then going to have a look and see, we're going to say, was our prediction, was our hypothesis correct? And then explain why you say that. Don't worry about your experiment. I am going to post a picture for you on Show My Homework that you need to cut out and put in there. And I'll pop that on for you. And then the last thing that you have to do is you have to tell me what are the best conditions for yeast to multiply. And that the control will tell you the most of those. The one that most of you don't get is the time. So yeast takes time to grow, which is why we make sure that we let yeast rest, dough rest, so that there is time for fermentation, for the growing of the yeast to occur. If you have any questions, please do email me or contact me on our class so that I can answer those for you.